Thank you all. When Alex said she was going to tell you a little bit about me, I got very worried for a moment, but thankfully you didn't find out too much, so that's okay. So hopefully this will help. This image that's up on the screen is from handwritten notes that are in the archives of St. Patrick's College. I'll tell you a wee bit about those afterwards. The main question, so I'm glad to see at least two other Monaghan people here this evening. So the main question I often get asked when people see my name is, what is it? Or sometimes they ask me, what is it in English? So that, just to improve my mood. So everyone should have this book in their library. History of Monaghan from 1660 to 1860. And I was lucky enough to read a copy of this. And one part, there's not much mathematics in it, but one thing it has a list of taxpayers in Monaghan. So Monaghan wasn't long planted at the time. And I don't know if you can quite see it, but the middle column is a list of people's names, the third column as well, and the first column is townlands in Monaghan, which you'll all be familiar with. I picked Cremorne and not Farney for these two venerable people in the front line. And you'll see all the things I've beautifully annotated there in blue, the blue of Anna Mullen. You'll see how my name is pronounced. Because when the English came and wrote down surnames, they did it in different ways, but one was they wrote it down phonetically, the way it sounded. So when they asked people what their name was, they said something along the lines of Mac Award. So they wrote down Mac Award. So that's what's written down there. And then they went, hang on, we already have wards in England, so we'll just call them wards. So most Mac Award in Ireland are wards. Okay, maybe you just don't know it. I had a student in first semester and her surname was Bhaird, B-A-I-R-D. So that was probably a situation where they asked what it was, son of the Bhaird. Okay, so my youngest daughter is very proudly Nick Award. Okay, so anyway, enough with that. So there is the Russell Library. I think the tours are tomorrow. Unfortunately, I can't attend the ones tomorrow, but I can on Thursday. And I first sat first in the Russell Library about 25 years ago. And when I went in there first, I remember very clearly because I was kind of like a child looking at a book. I was just looking at the pictures. But I had some awareness of the history of maths. I just finished my degree in mathematics. I didn't have much of a sense of the history of maths, but I knew some of the names. So I'm going to ask you some questions. Where did maths come from originally? What do you want to say? I'm going to guess what you're going to tell me, but people are saying the Greeks. Hang on, don't argue with me now. You've now spoiled the next 4 slides. So often we hear ancient Greece, and to some extent that is true in a sense that it was written down rigorously, just got proof. So I was explaining to my students, I think last week, what mathematical proof was. So if we get medicine, we're hopefully taking medicine because something had been tested thousands of times and it mostly worked. And that's probably where side effects come from the few times it didn't quite work. But mathematical proof always works. Okay, so that's the little difference. But if we just look at Greece for a second, what names come to mind for anyone? Pythagoras. Everybody says Pythagoras. Okay, so Pythagorean theorem. So let's just think about that for 1 wee second. Can anyone tell me what the Pythagorean theorem is? I got all the right elements. If you when I was younger, the Simpsons were still funny, and if you look up Homer Simpson saying Pythagorean theorem, you get an interesting interpretation. But he was just repeating what was said originally in The Wizard of Oz. If you go back to the original story, when was it the Tin Man that got a brain? Was that correct? He decided to quote the Pythagorean theorem to sound smart. Okay, so I'll just go over here. I didn't warn Tara, but I'm going to, just for 1 second, but what you told me is right. You got a right angle triangle. So something like this. That one side length is A, another side length is B, the third side length, the longest length is C, and you say A squared plus B squared is equal to C squared. And the nice thing about the Pythagorean theorem is that it also works the other way around. This is part of mathematics. If you guys give me 3 numbers such that A squared, the first one, plus B squared, the second one, equals C squared, the third one, that automatically means they must be sides of a right angle triangle. So there's 2 things in there. The order in this statement doesn't matter. Does that make sense? Orders of statements often matter. Okay? I just saw Richard. You correct me on everything I say. Okay. The other name we often hear of is Archimedes. Archimedes was unbelievable. What's interesting about Pythagoras is that almost anything you've heard about him, we have no idea whether it's true or not. So Pythagoras is roughly 4th century BC. And all the stories about him are stories that were written in books about what was read in books, that were written about what was written in books, and none of these books exist. None of these records exist. So all the stories you hear about Pythagoras, they're nice stories. We don't know if they're true or not. And as we'll see in a second, can he or she even lay claim to the Pythagorean theorem? That's also not clear. Archimedes is very important. If I have time at the end, I'll come back to Archimedes. But probably most people haven't heard of this name. So this is Diophantus. Okay, and Diophantus is very important to our story. Diophantus is a lot later. He's 300 AD. He lived in, he worked in Alexandria, what's in Egypt now. So this is 600 years after Archimedes, maybe 500, 600, and 700 years after Pythagoras, a lot later. So he's key to our story. So I had some sense of these guys. And that is the best image of ancient Greece I could get that was open source, so I don't have to say copyright. And when you talk about ancient Greece, people imagine that it is often modern Greece, but long ago, and that's not really true either. So a lot of the places we're talking about are along what's now the west coast of Turkey, but also the south of Italy. So we just got the heel here, but Pythagoras, if he or she existed, the center was on the very sole of the boot in Italy. That's where Pythagoras was. Archimedes, Syracuse, which was in Sicily. Diophantus was in Alexandria, which is in Egypt. So ancient Greece was very, very spread out. Okay, very, very spread out. But some people beat me kind of to the punch because maths is much older than the ancient Greeks. Okay, the evidence is more scarce, lack of sources, etc. But so this, hopefully you can see this okay. This is a very important, these caves on the not that far from Cape Town in South Africa. Human activity for a long time, 100,000 years ago, something like that. And this is just one particular example, and I'm just showing this to you. What is it? Don't know. But people would describe it as being patterns, that it's some kind of a geometric design, but another interpretation is that it was some kind of a keeping count, a tally mark. I have vague memories in my youth of doing silage at home, and it's not something I particularly wanted to do, but to keep count of the number of trailer loads coming in, you made marks not that dissimilar to this on the wall of the shed to count. So when Daddy shouted at me to figure out how many loads have been in, I was able to count it off. So it's possible. Who knows if that's exactly what it is, but it's possible that it's some kind of a tally stick. So this here is something called the Ishango bone. It's about 20,000 years old. I read previously, I'm not quite sure if you can see the marks, I read previously that it was a leg bone of a baboon, but apparently now they're not certain because it's been scraped and worn so much. But what's interesting is that they don't seem to be random. So these are a series of marks in the middle column. Just essentially, it's almost cylindrical, and there's a line of marks, and then you turn around a little bit, another line in another column. So that one has 48, not quite sure, but this one's much more interesting. Much more interesting because it adds up to 60. And the third column, when you do the tallies in it, they also add up to 60. So that's interesting because it suggests potentially it's something to do with keeping time, keeping track of things. A recent interpretation is that maybe it's lunar cycles, it's something to do with menstrual cycle, we don't know. So one interpretation, if you read about this, is that it was females in charge of that particular tribe, and this was some way of keeping track. I don't know, but it's almost certain that it's numbers as opposed to the last one, which was maybe, we're not quite sure. Okay, so that's the Ishango bone. That's about 20,000 years old, and no, but probably more the fact that more to do with months. Months are, like this is 20,000 years ago, so their months were more to do with like literally the moon, so maybe the seasons or something. I don't know. Anything that's a divisor of 360 makes you think that it's probably to do with time. Yeah. But if they're counting anything, they were probably counting days. Yeah. Okay. So somebody mentioned earlier Mesopotamia. Okay, so this is approximately 3,800 years old. Okay, so this part of the world, Mesopotamia, so literally the land between two rivers, so more or less modern day Iraq. Lots of things were invented there, writing. So this, what's written in here, this is called cuneiform, so that literally means wedge shape. So if you go to the tours of the Russell Library, you'll see some cuneiform tablets there. The idea was very roughly, it's essentially on mud. Let's say something roughly the size of this phone, roughly, put it into a tray, probably get a reed or a rush, and then you would make indents at different angles, and that essentially would be, it's not quite an alphabet, but similar enough in a sense. So lots of different languages would have been written in it. Can you see very distinct columns there? Do you want to know how to read them? Well, the one on the right you can read straight away, because that's just the numbers. 1, 2, 3, 4, 5, 6, 7. Where's 10? There's 10. Because the symbols, roughly, the symbol for 1 was something roughly like that. Let's not get too worried about it. So if you wanted 2, you did 2 of those. If you wanted 3, you did 3 of those. You kept on going. Clearly, after a while, you didn't want to keep doing these. So another angle was something roughly like that, and that was 10. So if you wanted 11, and 12, and 13, and 14. Is that okay? And what's particularly brilliant about these guys, we have a lot to thank them for, and you mentioned about time earlier. If you wanted to write down 60, because they counted in 60s, so that's 160. So what they did is, you know the way we count up to 9? It's full, move over to the next thing, keep counting the 9s, it's full, you go into 10s. They did exactly the same, except they went up as far as 59. So if you're looking at someone doing athletics, that's my best example, I think. You can see them running along going 58, 59. What shows up next? 1, 0. So 160 and no, let's call it units for the want of a better word. What's next? 1, 1. So that's 61. 1, 2, 62. You keep filling up until you get to 59. What happens next? 2. Exactly the same system as us, except they counted in 60s. but they didn't have a 0, so that made things a bit tricky. But this here is something called a Plimpton tablet. It's a column, it's a list of numbers. It's got different interpretations, but probably what's in there, Pythagorean theorem, some version of the Pythagorean theorem. So can anyone give me numbers that work for the Pythagorean theorem? Can you give me a number so that I square it to another number that I square it equals a third number squared? 3, 4, and 5. So let's go through that. I'm making you think. I'm going to apologize profusely for that, but sorry, can't even write. Let's pretend I was trying to see you're still awake. 3 squared is 9, 4 squared is 16, 9 and 16 is 25. Fair enough? Okay, so that they're called a Pythagorean triple. Once you have 1, you've usually got 2. Double those numbers for me. $36 and 64 is 100. Double it again, won't work. That's the problem with maths. You think, yes, I'm on to a good thing here. Doesn't bloody work, okay? But that's to do with common factors. There's no number other than 1 that divides into those. You see that there are numbers other than 1 that divides into these, like, for example, 2. Okay? So that seems to be a version of what's going on here, is that it's something to do with Pythagorean triples. Why? Not really sure, but it might have been to do with engineering, because what shape does this look that's useful for engineering is like a ramp. So possibly it was trying to measure angles. Okay, how do we know what they were doing almost 4,000 years ago? This is us with a modern lens looking at what they did back then. Okay, so whoever mentioned Mesopotamia. Back to Diophantus. So basically, when I sat first in the library, first around that time, I knew a little bit about Diophantus, and I knew something about a guy called Fermat. So Diophantus wrote 13 books, most of which were thought to be lost in Western Europe. And then something that was, let's say, helpful for Western Europe was the fall of Constantinople. I know that's a strange way of looking at it. But it was quite clear for a long time that the city was going to be captured, and for decades, maybe longer, people were fleeing to the West, bringing, for example, books with them, manuscripts, scrolls. So it's believed that some of these books were in the libraries in Constantinople, but Western Europeans didn't know. They thought they were lost, and then they brought them over. The problem was that at that point, the number of people that would have spoken Greek in Western Europe was relatively low. So if they were able to read or write a language, it was Latin. Okay? So this book was translated, well, the first widely translated translation of this book into Latin from Greek was in 1621. And Fermat was, I never quite know how to describe him. He was something kind of like, I'm not quite sure he was a judge. He wasn't a counselor really either. He worked, the title I've read on him as a counselor, but he worked in a kind of judicial service. I'm not sure exactly how to describe it. But he did maths in his spare time, so we all know how that feels. And he was reading this book, which I'm going to show you a copy of now, and he was messing around with it. You know, when you're doing your Sudoku or whatever, and you're doing little calculations. So this was what he was doing. He was reading it, he was thinking about it, he was making little observations in the notes. Okay, so when we're told in school not to write in the margins of your book, we'd be in serious trouble if people didn't do that in the past. And I'll show you why. So that's one page in the book. I don't know if you can quite see it, but when this Bashi guy translated it, the Greek text was all along one side of the page, more or less, and the Latin translation was all along the left-hand side. Okay, so this isn't the copy. This isn't what Fermat was reading quite, and you'll see why in a second. You'll notice, which always surprises my students, the complete. Services will cease in 15 minutes, and the library will close That's okay. I thought we were going to make an announcement about an inept guy working with PowerPoint, but that's okay. You'll notice, which hopefully you'll see, is that almost a complete lack of symbols. So my students often complain about algebra and can say it could be a lot worse. Algebra is extremely important. The big thing that's different here is that this isn't the book that Fermat was reading, unfortunately, because that copy is lost. So when Fermat died, Fermat lived from just around 1600, the early 1600s until about the 1660s. And after he's died, one of his sons, Samuel, came along, got his father's copy with all the notes and decided to print it again, but include all his father's comments. So basically, if you look here, like my Latin is non-existent, but basically what Dad said, observations of, Dad. Don't quote me on that, okay? So hopefully this will come up. Now, unfortunately, it's a little bit fuzzy, but this is possibly one of the most famous statements. Is that fair enough to say, Richard? One of the most famous statements in the history of mathematics, this, okay? And it's in Latin, but it says something like a cube has 2 cubes and a fourth power has 2 fourths. I'll explain what that means in a second. Keep on going forever, and there's no solution. I'll tell you what the rest says in a second. More or less what Fermat was reading, I'm being a bit generous with the truth here, but I am from Monaghan, so that's probably a natural state of being, is that he was looking at something along the lines of this. Not exactly, but let's say something along the lines of this. So you guys already agreed with me that you can write numbers, so 3 squared plus 4 squared equals 5 squared. There's actually infinitely many numbers you can find that work. You can also find infinitely many that don't work, but that's the nice thing about infinity. So what Fermat was thinking is, what if I change the power? What if I don't want to square a number, multiply it by itself? What if I wanted to cube it? So can you find a number? So I multiply it by itself 3 times. I find another number. I multiply by itself 3 times. Add them together. Will it equal a third number multiplied by itself 3 times? So that seems like that seems like a reasonable question. So not exactly sure what Fermat did, but he said no. And then he said, well, what if I change the power of 4? Or what if I change the power of 5? Keep on going. So Fermat said that he didn't find any numbers that worked. And then he said, best excuse for getting out of homework ever. He said, I have a truly marvelous demonstration, but the margin of the book is too small to write it down. That old chestnut. The dog ate my homework. So this was around, I don't remember the exact year, it's like 1630s or something like that when Fermat wrote that down first. And the problem was solved in the 1990s. 360 odd years of getting things wrong. And this is an extremely important lesson in mathematics, that particularly when students come in first year, I think the whole focus on maths is about getting things right. Most of the time people doing mathematics are getting things wrong. It's what you do next is the key. Does that make sense? So it took a long time. The story, if you look it up, it's called Fermat's Last Theorem. It's a very fascinating story if you look it up, but that's where it all came from. So this book is in the Russell Library.
Attention library users, the library will close at 10 p.m. this evening. That's 10 p.m.
I think that's a hint for me, I think. Okay, so this book was in the Russell Library. So when I got to the Russell Library first, about 25 years ago, I knew that book was there. My mind was blown already. I knew a little bit about Fermat. And another incredible book that's in there is Copernicus. This book by Copernicus from 1566. Okay, this book is, am I allowed to tell them it's worth a lot of money? Yeah, it's worth a lot of money, right? So we'll be watching you if you go near us during the tour. So this book, can anyone tell me why this book is so important? Or what did Copernicus do? Or what did he wait most of his life to do shortly before he died? Maybe that's a better way. the sky. So he was proposing a heliocentric theory. So a common accepted teaching from Aristotle in the church at the time is that the earth was the center of the universe. Okay? And people who looked at the sky, things weren't quite working out. Now, they weren't working out after this theory either. We'll see why in a second. But Copernicus proposed that it was heliocentric, so that the sun was at the center and all the planets went around it. So one of the most famous images from that book is this one. Now, I don't know if you can quite see it, but you've got Mercury. So later this month, we'll be able to see most of these planets. Fingers crossed there's no clouds. We'll be able to see most of these planets at the same time in the night sky, which is incredible. Mercury, Venus, the Earth with the Moon, Mars, Jupiter, Saturn, and then other. Okay, that's what was known at the time. So he was proposing this theory. He delayed publication because he was a bishop. He had a slightly strange position. I don't remember the title of it, but he was recognized as a bishop, and he thought he'd get into a lot of trouble, but he was dead when the trouble erupted, so it was okay. But what's the problem with that? The problem is that he was right, it's heliocentric, but we're not traveling in circles. Okay, so it's only a little bit later with Kepler that we figured out that it's not quite a circle, it's a different shape. That book was in the Russell Library. So I was absolutely amazed. So those are the two books I definitely knew about. But I'm going to come back to them later if I get to my point. So fast forward to 2016, you'll be glad to see that. So I was lecturing, as Alex said, in Maynooth since 2007, and we have a module in the history of maths, which at least one person in the university finds interesting. And I have been teaching it often. And often Alex and our predecessors would allow me bring the students into the library. So as this was going on, I began to get a better sense of the type of books that were in the Russell Library. And the students really, really loved seeing the books, really loved it. The book that blew their minds most was a book of log tables. Don't ask, well, I know why, but that really surprised me. And then I went to a conference in St Andrews about mathematical biography. I had a PhD student, and I happened to bump into someone called Philip Bealey almost by accident. So I didn't put up this photo, but Philip heard me talking about somebody called Huxley. There was a guy called George Huxley who was a professor here in Maths and Classics, and I was telling whoever this person was about the annual lecture we have in the history of maths, and someone said, "Oh, is that the George Huxley?" "Yes, his daughter's my landlady." And I went, "Yeah, if only we weren't in Ireland, I would have thought this is a typical Irish story." So the person whose landlady was George Huxley's daughter was Philip Bealey, the president of the British Society for the History of Maths and a fellow in the University of Oxford. Small world. And he told me that, in fact, he was coming to Ireland soon because he was doing a project on Euclid and he was going to go to Trinity College. And I said, "Why would you go to Trinity College when you can come to Maynooth?" Okay, that's probably more or less exactly what I said to him. Okay, so Philip was doing a project about Euclid's elements. I'm eventually getting to my point. Euclid's elements. So those of us that if your only dealings with maths was at school and your only dealings with geometry was at school, more or less you were studying parts of Euclid's elements. The further back you went in time, the more Euclid's elements was used in teaching mathematics. So the Pythagorean theorem is book 1, proposition 47. And book 148 as well, the inverse of it. So the results of Pythagoras, Archimedes, these guys, they're in the Euclid's elements. So what Philip was doing was looking at this book. And I've just said those two things, so we'll move on. So this is kind of interesting. I'm not sure how often it comes up in pub quizzes, but since books were printed, this Euclid's Elements and Maths book has had the second most editions. You wouldn't think it. Number 1 is the Bible, and number 2 is a maths book. How long that'll be the case, I don't know, but that's supposedly what it currently is. Now, I won't click on this link just in the interest of everybody's sanity, but I might move on to the next point. So there was a Reading Euclid project. I'll describe it to you. Basically, Philip and his colleagues were going around United Kingdom and Ireland, looking at copies of Euclid's Elements, because as the second most number of editions, there were lots of different versions, lots of different printing techniques. They were looking for differences. This is a very important point that I might talk about for a second. Philip told me recently that in the UK, funding for archive works and going to libraries has been dramatically reduced. And one of the reasons they're giving is they said, well, you can get the material online. So if something is imaged and put online, why would you need, whatever it costs to come to Maynooth to look at a copy? That's a very interesting point to make. Like, if everything is now going to be online, why would you want to see an actual specific copy? And we'll see why. So Philip came to Maynooth and it was great. So, I never asked him. I'm not sure. We'll see. We'll talk about the collection of Maynooth in a second. So at the time, this is something kind of slightly separate. When I spoke to Philip, they hadn't found, I'm going really off tangent now, but they hadn't found any copies of Euclid's Elements in Gaelic. So they were all through all the universities in Scotland and through at least one in Ireland. But since that, so I'm glad to see Siobhan here today, since that, by kind of using Twitter when it used to be useful, I found out about this beauty. Okay? So this is, unfortunately, only 16 pages long. And it is Euclid's Elements translated into Gaelic with the Shanachlo, with the old script. It's very pretty. This is how you create an equilateral triangle. So you intersect two circles and you do one specific thing and you end up with an equilateral triangle, three sides being the same. That's book 1, proposition 1. And it's in UCD. And I won't tell you the whole kind of convoluted story about how on earth it ended up in UCD, but we do know who wrote it. A very unexpected person, a guy by the name of Sean O'Donovan. So he was, if you know his name at all, it's as a Gaelic scholar. So he worked with the Ordnance Survey of Ireland in the 1830s. If you read some of the descriptions of what he did, it's unbelievable. You also find out that he was in very poor health, and you can see why. Sleeping under ditches, pouring rain, descriptions of weather in, Monaghan and other places, sleeping outside. But without his work as part of the Ordnance Survey, huge collections, like a lot of Gaelic manuscripts that we have now, sayings, place names, people's names, stories, a huge amount of that is due to him. This was part of what he did during the Ordnance Survey. So what I haven't been able to figure out, and I don't think you figured out either, Siobhan, is why did he do this? Did you figure that out? No. Yes, I'm not paying her any money to say that whatsoever. So we don't know. We just don't know why O'Donovan translated this. And this is the kind of tangents you go on. So hopefully there will be a PhD project out of this and we can try and figure out. The interesting question comes up then is, how was mathematics taught? Is that time already? Oh, no pressure then. Let me see what... Oh, great. 1/3 of the way through. Okay. So this is very interesting for me, because my degree was in Irish and mathematics. I had never taught to this point, is because such a large portion of the country were speaking Irish up until the 1840s, and if they were in schooling, in head schools or whatever, I would have assumed they were taught mathematics through Irish. So I know nothing. This is something that I want to try and find out about, like what mathematics, how were they taught mathematics? Was it taught through Irish? What text did they use? That's a whole world that I know nothing about and I'm hoping to find out about. Right. So I'll whisk through these pretty quickly. The thing that was interesting, so maybe I can put these slides can be shared later, Elaine, can they, or something, and all these links will work. That's the safest thing to do. Okay. So if you click on this link, you'll see a description of these books. So we had an exhibition of the Euclid's Elements in the Russell Library. So what Philip was particularly interested in is what was written in the books. So this was the first time I'd come across this. It was like the signatures, the annotation, the calculations, that type of stuff. That's what he was really interested in, not the books necessarily themselves, but what made these books different from identical copies that were in other libraries or online. So I hadn't thought about that before. So I'll just zoom through this. So Philip, I told Philip about my idea of trying to get someone in that knew what they're talking about, so I'm certainly not it, that would look at all the maths books in the library. So Philip conducted a review, and he told me, I remember him using the word amazed. I did not make that up. And I was trying to find out why he was amazed by the collection. He said because it's so different to the collections he would have seen in Britain. So we were trying to figure out why. Now it's still guesswork a little bit, but it's to do with how the university here was set up and probably who worked here at the start. So in Britain, often the collections were through the book trade in London. There was a very strong book trade through London. When the university was set up here, most of the earliest professors were Irish, but they worked in Irish colleges all over Europe. So they worked in Lisbon, in Paris, in Italy, in places all over Europe. And our best guess, unfortunately the records are very complete, but our best guess is probably when they moved back to work in university, they brought their private libraries with them. So that was the first day of teaching. And we know that the first person who taught mathematics was Peter Delors. So this is a little project of mine. If somebody wants to give me a little bit of money to send me to Bordeaux for a month or two, that's where Delors is from. We know very little about him. We know that he was in London. He was fleeing after the French Revolution. Don't know how he ended up in Maynooth. We can guess, but we don't know. And we basically know nothing. We know a little bit, but we know nothing about what he taught in Maynooth. Nothing. Maybe we will find it, but we know that day one in October 1795, he had 3 students in Style House. When you walk in the old campus, the first building you see in front of you was an initial building. That's where the college was. That's where he was. So we have to find out more about him. I'm not sure what there is to know. We do have this quote. I was going to leave this out, but I like this particular one. An intimate acquaintance of lingua, whoever that is. Lavoisier is a famous name. The bit at the end makes you begin to doubt this. He was so held in such high esteem that he was solicited by the fellows of Trinity College to become a professor of their establishment. Seems unlikely in around 1800, even though there was emancipation. At that stage, Trinity hiring a Catholic priest to teach to be a professor, highly unlikely. The source is very unreliable. If you want a good read about Walter Cox. He was constantly being sued about the things that were written in this magazine. Anyway, it's an interesting point. So Dare, have you been to Fusion? You have been to Fusion for it? So Fusion Hall is the canteen. If you pay for your food and come out, you're looking for a seat, just look over your right shoulder, and there's a painting up the wall of Dare. If you look closely, you see he's holding maths book. He's got, I'll call it a funny hat, and there's a glove. That's Dare. We know a lot more about Dare. Born in Toulouse, so if you want to fund me to go to Toulouse as well, that's also acceptable. Toulouse, where Fermat lived. And we know a bit more about him. We already know that he was in Ireland in 1793. So my colleague Rod Gow in UCD discovered an article that was written in 1913 in France. And Dare had written a series of letters to another French priest who was in Spain. So there were letters over and back. Unfortunately, almost none of the letters were written while he was actually in Maynooth. So it's really useful, but with limited use in the sense, so we know a bit more about it. He was generally ill and unhappy in Maynooth, and thankfully those days are long gone for all of us. But he seems to be very well connected. He was very closely connected with William, was it the Duke at the time? Was it William Fitzgerald? 1790s, 1890s? Robert. He was very, during various, I think it was 1798 when there was some new rebels, they went to Dare to intercede with the Duke because he knew he was so close. He used to go once a week for his dinner and different things like that. Anyway, he produced a book. He said in the book that he was going to produce more books for new students, but he was already left Maynooth before the book came out, so some people questioned the veracity of that. Let me move on to it. So other sources. This is the nice stuff. There are about 100 handwritten notes in the archives that we've rediscovered relatively recently. Almost certainly they're diaries. So this is something that's fascinating, and they were written probably some of them in 1783. So I want to show them to you. So that's kind of hard to see. This was one of the few in English. It says examinations of the class of physics for the year 1804. So this is in English, and as best we can tell, he's describing probably for his superiors what he's teaching in class. Probably. I'll move it through. It seems pretty extensive, particularly because, and this is where we were complete guess what, we're complaining about the mathematical standard of the students coming in. Things have not changed. So what we have been able to find out is that when students come in, there weren't, as far as you can see, any mathematical prerequisites. So there might have been a little bit about having to have Latin, or maybe read the classics, something like that, but as far as we can determine, there was no mathematical standard. So I'll just skip through this because I want to show you the issues. So this is the type of stuff we're dealing with. This one was preserved. You can see this is all in French. A little bit of calculation here is relatively straightforward. It's lines, simultaneous equations, that kind of stuff. That's a bit of a close-up there. What's particularly interesting in one of them is we get some kind of clues as to the sources. So there's a reference to a guy called Bezu, page 101, Lingua 158, Marie 247. So there's another project I'm hoping to get involved with, if some of you give me money, to go to France and track that. So we know that these authors produced mathematical books for teaching mathematics in France in the mid-18th century. So there's lots of editions, but trying to somehow link these notes to those books to see how far back we can go. It's only interesting. The problem with these notes is they're all incomplete. So there might have been 3 or 4 different sets, and we have book 2 of 7, and maybe book 3, and then we want another one. Lots of them are missing. I'll skip the student notebooks just because we move on. I'll leave Cornelius. Well, actually, Cornelius Denver is interesting. Darian was replaced ultimately by Cornelius Denver. Very, very interesting. He later became Bishop of Down and Connor. He's the first person we believe that brought in equipment for experiments. So Darian and there were no experiments that talked about physics. I won't possibly comment on whether that's the best way to do physics or not. But we know that Denver bought equipment, and quite interesting, there are letters in the archives from Denver, when he was Bishop of Down and Connor, to Callum, Nicholas Callum, the students, talking about how to get copper wire to run their experiments. So Denver continued to run his experiments in Belfast. I'm going to skip all these because I've been talking about. So these are the idea. You see the state of some of the notes. These are all stuff that we're trying to look at. Maybe this is an interesting question. Why teach maths to seminarians? So here is, I think it was Crotty. So the president of Maynooth was interviewed. If you look at this particular report, it's all about maths. So clearly they were looking for something. And this is what the president said. The study of maths, we attend to more for its tendency to introduce correct habits and reasoning upon other subjects than for any immediate value or necessity of mathematical knowledge to a clergyman. Okay? So, you don't need to read all that. Let's just go down and look at the end. The end says, a knowledge of mathematics affords them a rational mode of amusement and of spending their time when their clerical studies will allow them to have recourse to it. So more or less, when you're finished with the parishioners, you'll be able to do some maths to relax. This is what the president of Maynooth said. So I'll skip Callan, and I'll skip all those. Because I want to get on to show you some notes. So I have lots of links here. The online exhibition, so maybe I can do this with Elaine. There is a virtual exhibition of the exhibition of the Russell Library, so maybe that's the last thing I'll show you here. I'll get Aaron back to show you that. So I just want to show you a couple of books from what we found. This is one of my favourites. So John Carty's The Element of Algebra was a book used for teaching maths. There's the title page from 1673. So this is kind of the typical stuff that you see in these books. This is probably Charles Wallace. So this is Philip Neely who wrote this chapter. Philip could not find out anything about Charles Wallace. Okay? It looks like it's 1688 or something like that the year it bought. We got the price. And then it was donated to probably Thomas Wallace. That's the end of that story, because Philip wasn't able to find out yet who these people are. Couldn't find any records on who specific people were. So that's one small thing. What's nice in this book is that there are little notes. So I haven't shown them all, but as you go through the books, there will be little marks, and somebody who's clearly studying it. But you have in the margins twice this quite brilliant note. And I've zoomed in so you can see. Thou art a very hard book. Another satisfied customer. It's quite interesting. Someone was clearly studying this book and not once but twice wrote this in the margins. So, the next one, I've been tempted to write this up as a story, just with this heading to see if I'll get any traction. Modern man says there's a plot to assassinate King Charles. You notice I didn't say which King Charles. So this book here is from Salamanca, the New Testament book collection from Salamanca, when the Irish College closed in Salamanca in the 1950s. We've got some of the books and materials. Maybe you don't, might not be able to see the Irish College. It says that it's written in that. This book is about comets. There was a comet in the early 1600s, I'm not sure, it was 1604 or something, and Zamora wrote this book about it. Okay. What's interesting here is what was found inside the book. This was found inside the book. So this, what size is that, Alex? Like, is it posted like half the size of my phone? It's about this size, little piece of paper. Possibly a bookmark. Maybe it was a bookmark. I don't know. Don't really know how it ended up there. It was forgotten about. It's written in Spanish, and possibly make that up Jerome's. So basically, Jerome is Sweden. And we'll see what it says. So this Jerome Sweetman was born in Dublin. He trained to be a Jesuit priest. He spent most of his life in Spain, Salamanca, Seville, different places. He had a mixed career. He was supposedly a very good teacher, but also got into trouble for various reasons that we won't get into. And this is more or less what it says. More or less, we want the priest to say a mass, and this is the money. So he's just describing he has so many, whatever the currency was, and he's saying so many masses, and this is the amount of money at the moment. So it's just a little note saying this is the amount of money. Fine. So, we don't know how it ended up in that book, but Sweetman is very interesting because of something called the published plot. So, I won't go into this in any details, so this is my colleague from St Andrews who worked in this chapter. So, Titus Oates was kicked out. Titus Oates was kicked out of the Jesuits. I'll keep this as short as possible so I don't tell you too many lies. And he wasn't happy about being kicked out. So, more or less, he made up a plot, a fictitious plot, to assassinate Charles II of England. And he implicated names of people who were, I would say, probably people that he felt wronged, people that were responsible for him getting kicked out of the Jesuits. And Jerome Sweetman was one of the people that he implicated in the story. Thankfully, a couple of years later, I don't know, people here know more about the story than I. I assume he was hoping that they would all be executed because they were plotting to kill the King of England, but the English found out relatively quickly that the story couldn't have been true. Okay, But that's interesting. So this little book about comets has this little note from Sweetman in it, so that's quite interesting. And I've got to the last one, so I skipped lots of stuff. So this is the real highlight. So if you don't get to go on a tour, please come again to see this book. This is a shorthand version. A lot of this is the title of the book, so I'm not going to read it all out. We call it Stormy's Mariner, usually 1669. It's amazing. You can possibly even see from you can already see the annotation. There's the surname Thornton there, there's other names around, there's lots of annotation on it. You can even see the inside. Okay? So why is this interesting? This book is very much a how-to. 2 minutes. It's a how-to book. It's a how to do everything. So there's dialing, there's signalling, there's studying. If you're at sea and you want to measure the height of an island, the highest point of an island, all calculations. Very much a how-to practical book. But it's beautiful for lots of reasons. There's lots of little rhymes and poems with doves, 2 ends on cold weather, different things. It's unbelievable looking book. But what's particularly interesting is this. Okay? So this, you can see all the calculations here only on the right hand side. Okay, so I'll keep this short. There's 3 pages of them on this. So, I'll say, no, I didn't do those. Yeah. But the first one is the brightest. So what's going on? One of the sections is about how to calculate latitude. So how far north or south you are on the Earth's surface, in the northern hemisphere. At this point in 1669, there was no accurate way of figuring out longitude, so how far east or west. Okay? So if you were out of sight of land, there was no accurate way of figuring out how far east or west. Okay? So in this book, there was a list of instructions about how to calculate your latitude. And what Boris, who was working on this book, discovered these calculations is you keep getting similar answers. 37, 37, 37, 37, keeps on. So he found about 3 months of calculations of latitude 37. So why would that be? Probably sounds like about the length of time you need for a voyage. Latitude 37 more or less goes from let's say more or less from Spain, south of Spain, North Africa, to more or less now Virginia, the US. The southern bit of Virginia, North Carolina, where the town Jamestown was, which was, let's say, the unofficial capital of British colonies there. The first main permanent settlement. So Boris went and checked, and 3 months of calculations is slightly long for a voyage, but not unheard of. So he was guessing, okay, it looks like somebody was calculating latitude 37 for 3 months. Why? Well, how would you get from, say, Ireland to, say, Jamestown? Probably what you would have done is you would have left Maynooth in your sailing ship, down the coast, keep going inside of land until you hit 37, and then go in a straight line. And then every so often, do a calculation, see where you're at 37 if you weren't making an adjustment, and keep going in a straight line until eventually you saw land. You saw land, and you followed the slides to go to the right place. That make sense? So that's the theory, very conveniently helped by what was on the front cover, inside the front cover. You can see lots of messing on here, there's different things, torn again and different stuff. But here, conveniently, there's a list of people's names. Mary Van, Bhaird, Dunn. These are names or something. You can make them all out. I think there's 12 or 13 names there. Some of them are very common, but a couple of them are unique, relatively unique. And Boris looked up the records from around 1700 in the American colonies, British colonies of America, and he found records of 2 of the less common names there. Now that's not definite, we don't know it's the same people, but it seems that this book was used. Was it used to navigate the ship? It's not clear, but maybe it was an apprentice who It was learning how to navigate, and they were mirroring the calculations or something, but this book was on a ship, probably at least twice, going across the Atlantic Ocean. Probably in the 1680s, we don't know the exact year. And what's also interesting is we have no idea how it ended up in Maynooth. It's just there. The Russell Library has been for a long time, so somebody at some point bought it and brought it into the collection. Now, I think that will do.